Hello and welcome to Code with Sar. How are you doing today? Starting from this video, we're going to talk about how to build a backend for the Fishcard website. For those new, if you do not know what Fishcard is, go to fishcard.codewithstar.net and try to search for fish to buy. We have been so far building the front end using Blazor WebAssembly, and we are going to build an API for it. The plan is to start with something abstract like the concept. Then we look into ASP.NET Core technologies to learn how to build a general web API. After we know the basics, we're going to build an API for the Fishcard, and then we're going to wire everything up. My goal by the end of this series is for you to have a solid foundation to build a RESTful API with ASP.NET. This is the first video, there's going to be no code, but it is important because we're going to talk about concepts. Let's get started. Coming next, you're going to hear me talking a lot about RESTful API. But what is a RESTful API anyway? There are two concepts, RESTful and API. Let's start with something simple, API. API stands for Application Programming Interface. So it is actually interfaces to allow different applications to talk with each other. For example, if you build some sort of like a bird application and it talks with the backend, the bird application and the backend runs on different computers. And when they communicate, what do they use? An API, right? Another example for API is the .NET code that we are writing. We call into .NET runtime, aka CLR. We call .NET a framework, but at the end of the day, it's a set of APIs. And we're going to build a web API project. If you haven't already, you're going to get more familiar with it. Now, since we are excellent engineers, right? Not only are we going to build any web API, we're going to build a RESTful API. But what is RESTful? Why we call an API RESTful? Or how can we call an API RESTful? REST stands for Representational State Transfer. It is upon request, the server will give the client a representation of the state of the requested resource. Now we are talking about two parties, the server that holds the resource and the client requesting it. And what the server returned is the state of the resource. So it's simple. For example, the client asks for a book. The book is a resource. And the server returns a representation of the resource. For example, title, author name, and the price of the book. And that is one representation of the book that this specific server returns. And if you have a service like that, that is a RESTful service. Well, that is very generic. And it almost feels like any service could be a RESTful service. Matter of fact, it's not the case. Because there are some very specific architectural constraints. There are 5 of them. Coming next, we're going to go over these one by another. We're going to talk about what they are and why. And in the future, we're going to talk about how to build the web API to satisfy these constraints. Oh, by the way, you don't need to memorize these one by another. Go search for RESTful API online, and you're going to see every place is talking about these constraints. It is more important to understand why they are there. Okay, let's start with the first one, client-server architecture. Client-server architecture is simple. There's a client, then there's a server. The purpose of it is to isolate considerations. The clients are mainly focused on user interaction, user interfaces, and user experiences. You could have a very basic login page like this, for example, on the client. Or you could put a level of style on it. The point is, how users interact with the client doesn't concern the server. And the other side, on the same coin, is that the server focuses on data storage, file system, caching, database, all kinds of these things. It's the same principle that any server change does not concern the UI. For example, you could store simple data in a JSON file that is on the file system at the very beginning and later on move to a database. And that should have zero impact on your client. In other words, it doesn't impact UI at all. Rule number 2, stateless. Now, this one is confusing. Did we say the S in REST stands for state? And why is it stateless? Let's go over the definition first. The server does not store any state about the client session on the server side. So this is not talking about the state of the resource. It is the state of the client session, or rather stateless of the client session. Okay, now why do we not want any client session information on the server side? Imagine we already have a RESTful service, and this client and the server. The client is sending request to the server for the first time, and then for the second time. And what would happen if the server allows client session? Well, we could do something like this. The first request, we're going to use it for authentication. And upon the second request, we're going to return the resource, but only back to clients that has already established an identity. It is actually convenient. But remember, it is a trade-off. For it, we establish a dependency in between the first request and the second. And this dependency will cause trouble. Imagine the service becomes a hit, and there's not enough server power for all the users. What we would want to do? Scale out to multiple servers, right? Now, if it were the server holding all the client states, we would then have to making sure that the second request always go to the same server as the first one. The situation right on the screen, that the second request goes to a different server, would fail. Now imagine you have thousands of clients and a couple of hundreds of servers. That's going to be a nightmare to maintain. But instead, if we say any request need to be on its own, there's no client session info on the server, any request can go to any server. That makes scaling much easier. Plus, if any server need to restart, just restart it. Other servers would be able to kick in and load balancing. The service will become more reliable. And that is statelessness. And by the way, if it would be for me to say, I would call it sessionless rather than stateless. Next, cacheability. Responses must implicitly or explicitly define themselves as either cacheable or non-cacheable. And so the definition is very clear. Well, it constrains responses. Just to pay attention, it is not saying the response has to be cacheable. It is more about marking the responses so that we understand whether that is cacheable or not. For example, if you have a server in the Europe and you have clients in the US, a request and response cycle is going to take a bit because of the physical distance. If we know the response that could be cached, we could introduce a CDN in the middle. And then, obviously, the clients in the US are going to talk with the US CDN. But hey, not every request is cacheable, that it is important to mark them clearly. And that's why cacheability. Layered system. A client cannot ordinarily tell whether it's connected directly to the end server or an intermediary along the way. What? Let me explain. Let's begin with a simple client-server system. The client sends a request for a resource, and the server gives it back. What a perfect world. Except there is a malicious cause, and we add a firewall in the middle. Okay, to make it secure, we add another layer of authentication authorization. Now, as we gain more user, we add in another layer of cache. And even that's not enough, and we're going to put in a load balancer. A request goes through this hierarchy level by level or layer by layer. For example, the firewall checks the package, making sure it is not malicious ones, and hand it over to auth for authentication. Authentication layer checks the identity on the request and making sure that the resource is authorized for accessing. And then it forwards it on to the cache layer, so on and so forth. But the point is, for the client, it sees none of these layers. What the client understands is that it sends a request and it is expecting a response. The benefit to the client, everything's simple. And to the server, different layers focus on its own expertise or its own domain. And the whole system is flexible. For example, some systems just don't have firewall, some systems don't have cache, some simple ones don't have load balancer. Totally valid. It is also easier to build a core of the system and then start to adding layers later. And because we designed the layer system to begin with, the client doesn't know anything about these layers, so it doesn't need to be updated when we're adding or even taking out any layer. And that's a layered system constraint. Last but not least, uniform interface. Remember the first constraint, server-client architecture? In between those two, it's always request-response pairs. To make a service RESTful, there are constraints for the request and the responses as well. For a request, it will always have a resource identifier. We are talking about abstraction here, but you must be very familiar with this concrete example, URL, and it is almost always used as a resource identifier in a web API. Back to abstraction, the key is it is a resource identifier. And with regarding the responses, they should have unified format like a JSON or XML or even HTML. On top of that, they should be self-descriptive. What does that mean? So if the response is in format of JSON, it should have metadata to help the client understand the format for the response is in JSON. And the same rule applies to XML or HTML or whatever format that you decide to go with. Also, in the responses, you will find hypermedia. What are those? Those are generally links to transfer the resource to another state. I'm thinking about talking more about hypermedias in the future. It would be easier if we had a concrete API to talk about. So in summary, the client sends a request to the server for a resource. Whatever the backend does, it returns a response in the format that the client can handle. And then we repeat the request, get more response. And just like that, that's the whole story. Quick recap. For an API to be RESTful, it needs to satisfy some architectural constraints, and there are 5 of them. Client-server architecture isolates the purpose into front-end and the back-end. Statelessness enables the scalability and brings in reliability to the services. Cacheability makes it possible to improve the performance. Layered system breaks it down to different domains. It makes it simple to add or remove functionalities. And the uniform interface simplified the communication between the client and the server. Now think about it. All these together makes the system scalable, performed, flexible, reliable, yet simple to build and maintain. No wonder this architectural style is so widely adopted by the industry. And in the next video, I'm thinking about we together look into how to create an ASP.NET Core web API that adhere to the REST architectural constraints, aka a RESTful API. I'm looking forward to see you there, and I hope you find this video useful. Like it or leave a comment below to let me know. Keep coding, keep improving, and I'll see you in the next one. Until then, take care.